Hello, everyone. Here we go with Unit 2, Lesson 7. We're getting close to the end of the unit. This is our second lesson on standard form. In the last lesson, we introduced standard form, what it is, and how to graph using that, and then also how to move from standard form to slope-intercept form in order to find certain information. Today, we're going to take a look at when to use each method in graphing lines, so standard versus slope-intercept, and then explain or can write equations in standard form from a word problem. So we're going to do some word problems with these. Good news is with those word problems, they're usually not too tricky. So what I'm going to do here with 1 through 4 is I'm going to try to use intercepts on all of these because they're all in standard form. I'm going to try to use intercepts, which we learned in the last lesson, to figure out how to graph these. All right, so let's go ahead and do that. I'm going to do it kind of quickly. X-intercept, that's when y equals 0. So the y is gone. 6x equals 12, x equals 2. We'll go ahead and plot that point. Y-intercept then would be when x is 0. I get negative 3y equals 12. Divided by negative 3, I get y equals negative 4. Okay. And we drew the line between them, and there's our line. All right. Second one. X-intercept. Let the y equal 0. I get x equals negative 4. 2, 3, 4. Put a dot there. Y-intercept. I get 2y equals negative 4. Divide by 2, I get y equals negative 2. Draw the line. Okay. All review so far. So what's different? Let's go down and look at 3 and 4 real quick. All right. Number 3, x-intercept. Cover up the y, 5x equals 8. Divide by 5, and here is our first issue. 8 divided by 5 is 1.6. That's not a great number to place on a graph. 1.6, you're going to be guessing on where that's at. It's between 1 and 2, a little bit closer to 2, but we don't like to do the guessing game. So what do? Okay, well, we learned in the last lesson how we can move this into slope-intercept form. Let's do that. So we're going to move this into slope-intercept form. So to do that, I'm going to subtract 5x. So I get 2y equals negative 5x plus 8. Divide by 2, divide by 2, divide by 2. I get y equals negative 5 over 2, which cannot be reduced. 8 divided by 2 is 4. So I'm going to go up to 4 and go down 5, right 2. And there's my line. Again, look where it crosses the x-axis. It's right there between 1 and 2, a little bit closer to 2, like we expected. So it's not wrong to use intercepts here. It's just not as easy to use intercepts here. So we have to do another method, and that's what I just did. I transformed it to slope-intercept form. Last one here, the x-intercept. Cover up the y. Divide by 3, x equals 15. And that is another problem. 15 is way over here on my graph. Doesn't fit on my graph. What are we going to do? Well, I am going to do the same thing I did with number 3. I'm going to subtract 3x. So I get negative 9y equals negative 3x plus 45. Divide by negative 9. I get y equals negative 3 divided by negative 9. Be careful there. That's a negative divided by negative, first of all. So it's going to be positive. And 3 and 9 reduces to 1/3. 45 divided by negative 9 is negative 5. So down to 5. Up 1, right 3. And if I would do that over and over again, I would land on that dot that's way out here, like I said. It just wouldn't fall on the graph. All right, so let's summarize what we just did. Most of you probably could by now, but I'm going to make sure we're going to summarize this. What form were each of the 4 lines in? They were all in standard, right? When in this form, we typically use this method to graph, and that would be using intercepts. For which graphs was this method difficult? Well, the last 2, 3 and 4. Why? Well, here's what, make sure you see this. When are intercepts not good to use? When you have, I don't know if we call them bad. They're not really bad, but when you have bad x-intercept or y-intercept. If they're not a whole number, it's hard to graph them. Or when the intercepts are off the graph. Okay. What should you do in those cases? Move the equation or transform the equation to y equals mx plus b. Okay. What I find usually, done this for a long time, is a lot of people just automatically move it to y equals mx plus b, even if there are good intercepts, and that's fine if you do that. You will have to still find intercepts, but if you'd rather put it in slope intercept form, that's fine. All right, let's move on to word problems. Good news is with these, I said it earlier, these are usually, once you see the patterns, pretty straightforward. Okay. So Greg makes $10 or can make $10 per hour mowing lawns and $8 per hour at McDonald's. Greg wants to make $200 so he can have some spending money for the weekend. So looking at basically a week, maybe. Write an equation to represent this situation. Let X equal the number of hours mowing lawns and Y equal the number of hours working at McDonald's. So if X is the number of hours mowing lawns and he makes $10 per hour, we can write 10X. And Y is the number of hours working at McDonald's, and it's $8 per hour, 8Y. If we add those two things together, we get his total amount that he makes, and he wants that to equal 200. And look what we have there. That's an equation in standard form. What is the x-intercept? Cover up the y. 10x equals 200. Divide by 10, you get x equals 20. What does that mean? Well, that's the point. Remember, that's the point 20, 0. That would mean 20 hours mowing lawns, 0 hours at McDonald's. So what does it mean in this problem? That would be what it would take working only by mowing lawns. So I'm going to shorten that down to only mowing lawns. Make sure you heard what I said, though, the whole thing. Okay. What does it mean in this problem? It's what he would need to meet his goal of $200 by only mowing lawns. You could probably guess what the y-intercept means here. Let's go ahead and figure out what it is. So cover up the x, I get 8y equals 200. Divide by 8, you get 25. That would be what he would need to do to make $200 by only working at McDonald's. Okay. So it was a couple situations now using the equation. It was a rainy week. So Greg was only able to mow for 4 hours. How many hours does he need to work at McDonald's to reach his goal? So what I need to do here is I've given you that he was able to mow for 4 hours. That's an X value, right? So I'm going to put that in for X. And I'm looking for Y. How many hours would he need to work at McDonald's to make $200? Well, let's solve it. So 40, he made $40 mowing. How much money is left? I'm going to subtract 40. I get 8y equals 160. Divide by 8, I get y equals 20. He would have to work 20 hours at McDonald's on top of the 4 hours mowing. So this point right here, 4 hours mowing and 20 hours at McDonald's would be on the line made by this equation, because it's a combination that gets him exactly $200. All right, one more question from this equation. After 5 hours at McDonald's, Greg was fed up and quit. He hated that job. How many hours of mowing does he need to complete his goal, reach his goal? This is a y value this time. So I'm going to put 5 in for y. And that's going to give me 200. 8 times 5 is 40. Subtract 40. He needs to make $160 mowing lawns. Divide by 10. He would have to mow lawns for 16 hours. So that would be the point 16. X is 16. Y is 5. That point as well would be on the line created by this equation. Okay. Now I told you that these word problems aren't bad because they follow a similar pattern each time. You've only seen one problem, so there's no pattern developed. As soon as you see a second problem that has a very similar situation, you start to see the pattern, hopefully. So this is a true story. In college, I had a job where I had to load softener salt into people's cars. The salt bags came in 50-pound and 80-pound bags. A customer one day asked for a ton of salt, literally a ton, 2,000 pounds. He, had a pretty big truck, loaded all this salt in his truck. It was a fun day. Write an equation to represent all the possible combinations of salt bags this customer could receive. So we had 50-pound bags. So I'm going to do 50x. We had 80-pound bags, 80y, and I wanted to make that equal 2,000. Now I got to determine what x and y are. I told you in the previous problem what x and y were. X is going to stand for the number of 50-pound bags. So if you got two 50-pound bags, 50 times 2 would be 100 pounds. That's what 50x is standing for. Y would be the number of 80-pound bags. So graph your equation and label your axes. So when I say label your axes, I have a couple things you need to do. You need to tell me what the axis is standing for. So I'll do that first. And I just kind of explained it by defining my variables. The x variable is the number of 50-pound bags. The x-axis is the same thing, number of 50-pound bags, which means the y-axis would be number of 80-pound bags. I also have to give the scale of this of the axis. So I got to put numbers down there as well. Before I put the numbers on there, I'm going to find the x and y intercepts because I don't really know how big this is going to be. So the x-intercept, cover up the y, divide by 50. I get, that real quick, 40. So I know my x numbers are going to have to go all the way up to 40. Keep that in mind. Y-intercept, 80y equals 2,000. Divide by 80. You get 25. So my y-axis is going to have to at least get to 25. So we're going to have to scale this a little bit. I don't have 40 lines, so I can't do each line as 1. Maybe I do each line as 5, because those are both divisible by 5. I'm going to go by 5. So we'll say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So each line is worth 5. And I'll do the same thing going up the other way. So 10, 20. If you want to write each one, so 5, 10, 15, 20, that's fine. You can also just do that. Okay. And we already found the x and y intercepts. Let's go ahead and plot those points. So the x-intercept was 40. Okay. The y-intercept was 25. And there's my line. Notice I didn't extend it in both directions because X cannot be negative. I can't have a negative number of bags, and the Y-intercept cannot be negative. Can't have a negative number of bags. So I stop at both of those intercepts. Any possibility that they can do would be on that line, and that would get them exactly a ton. Now I'm gonna get rid of all this. Hopefully you have it written down because I'm gonna use this stuff to finish up the last few questions. But I need to clear it because I need to move down. All right, the customer said that when he unloads the salt, he wants to make as few trips as possible from his truck to his softener in the basement. Assuming he carries one bag at a time, which combination would best suit this customer? Well, if he needs to carry one bag at a time, he wants to carry less. He wants to make less trips. Which one of those two intercepts had less numbers? That would be the Y-intercept. So the 80-pound bags. He didn't say weight was an issue. I know you might be thinking, I don't want to carry 80-pound bags, but he doesn't say that weight is an issue. Some people, it's not. So he wants 80-pound bags. Okay, which combination would best suit the customer? Well, all 80-pound bags. And so that combination would be 0 50-pound bags and 25 50-pound bags. That's right, 80-pound bags. And that would be the combination that would suit the customer the best. All right. Last part there, as I was loading his truck, I realized that I was going to run out of 80-pound bags before he received his ton of salt. I ran out of 80-pound bags after giving him 15 bags. How many 50-pound bags do I need to give the customer to meet his order? Well, I gave him 15 80-pound bags. That's a Y value. We're looking for the X value. So that was 50X. And again, we want to get to 2,000. So 80 times 15. 1,200. So 50X plus 12. He's already got 1,200 pounds of salt. How many more pounds does he need? He needs 800 more pounds. Try that again. That looks like an 8. Oops, sorry. So 800 divided by 50 would be 16 bags. He would need 16 50-pound bags to get his ton of salt. Okay, and so all of these word problems kind of follow the same pattern. It's just identifying these word problems versus the ones that we've talked about in earlier lessons. And we'll work on that as we get ready for the upcoming quiz and test.